Assalamu alaikum, everyone. Welcome to our webinar, Asset Stimulation Overview. I'm Abdullah Abdurrahman. I'm a reservoir engineer into Reservoir Solutions company. Just I would like to make 5 minutes presentation about our company and also to introduce our instructor, Engineer Ahmed. Then we will start our webinar presentation. So for Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. The company incorporates many professionals with diverse technical background related to oil and gas exploration and production. Our services includes technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researches like PhD and master degrees. We are assisting in writing technical papers and publishment. Also, we are providing technical petroleum courses by industry expertise. Also, we are providing mentorship programs. Just for the 2 upcoming courses, we have 2 upcoming courses in August and September. The first course is hydraulic fracturing, pre-job design, execution, and post-job evaluation. It will be 1 week hands-on experience workshop. You will learn many things related to hydraulic fracturing, like how to select the candidates for hydraulic fracturing, how to design the operations for the hydraulic fracturing, also how to know the geomechanical properties for the reservoir, how to select propellant and fluids and additives for the hydraulic fracturing job, also how to make design for the hydraulic fracturing job, how to make analysis for the pumping schedule or the pumping data like mini frac analysis and the other analysis related to hydraulic fracturing job. Also, after the job, how to make QC, QA, and QC for the hydraulic fracturing job. Anything related to the hydraulic fracturing using software to design and implement the hydraulic fracturing job. Also, the advantage for this course that you will have lifetime access to the recorded sessions. So if you have any issues related to the timing for the course sessions, you will have lifetime access to the recorded sessions. Also, you will have data sets to apply on softwares or because the workshop is application based. Also, we are providing course material like the PDFs, the Excel sheets, and the data sets. You will have open discussion with the instructor during and also even after the course. So if you have any question related to the hydraulic fracturing after the job, you will have the chance to discuss that with the instructor. At the end of the course, you will have certificate with online identification ID on our website. For the course content, I will send a link for the course content. And also, if you wanted to register for this workshop, you will have, I will send a link to registration into the Zoom chat. The other course is for the borehole image processing and interpretation. And actually, it is the first time that course will be implemented as online. So that course, it will be 2 weeks hands-on experience workshop. Also, we will use software for implementation and application for the processing and interpretation for the FMI, OBMI, and XRMI logs using the software. For this course, you will learn the application for the borehole image log. You also can do processing for the borehole image, quality control, do manual depth picking, interpret reservoir extraction and stratigraphic, also do structure depth analysis, also make depth azimuth vector outplot, also calibrate image by the core data, integrate wireline logs with the borehole image. So if you wanted to have complete interpretation using the conventional logs like gamma ray, neutron density, and the resistivity, plus the FMI or XRMI or any logs or any borehole image, or also again, also plus the acoustic borehole image, you will you can do processing and interpretation for these logs by learning that from this course. Okay, many other things that you will learn during this workshop. It will be 2 weeks hands-on experience, so it will be very, very good chance for you if you wanted to learn about the borehole image processing and interpretation. Again, if you wanted to have more details about the course content, I will send a link for the course content in the Zoom chat. Also, if you wanted to have registration for this course, I will send a link for it on the course on the Zoom chat. For our webinar today, the instructor for our webinar today, he is Engineer Ahmed Al-Hadidi. Engineer Ahmed Al-Hadidi graduated in 2013 from Bursaid University. He have a huge experience related to the petroleum engineering. He worked as assistant lecturer in the Bursaid University. He was a petroleum engineer in Trident Petroleum Company, joint venture of Magawish. He worked also as petroleum technology engineer in Khalda office. Currently, he is team member for hydraulic fracturing and team leader for acid stimulation and coiled tubing operation. Again, as usual, the webinar rules, if you wanted to ask any question related to our webinar, just drop your question into the Zoom chat, mute your microphone and camera. If you would like to have a certificate for attendance for this webinar, you can fill into the form that will be sent into the Zoom chat. For upcoming courses and webinars, you can join our Telegram channel and you will have our contacts for more details. Thank you all for your attending this webinar and hope you nice learning journey. So Engineer Ahmed, you can start your presentation.
Thank you, Engineer Abdullah. Thanks for all. Give me 1 minute to show my presentation.
Okay.
Hello, everybody. It's my pleasure to meet you today about our webinar for the formation damage and the treatment strategy as acid stimulation techniques. So, first of all, our agenda today, we are going to talk about the formation damage definition and its description and diagnosis of the types of the different type of the formation damage, the natural and induced damage, and how we can improve or bypass this damage by a stimulation technique for the acid stimulation, either in sandstone or carbonate. So the first topic is an overview of the formation damage. What is the formation damage? It's a general terminology used a lot in the petroleum industry, referring to decreasing in the permeability zone. This damage is often expressed by the skin or zonal damage. It's generally limited in the reservoir look within a couple of feet, and it's a rule of thumb about its range from 3 to 5 feet near the well pool. The formation damage is caused by different operation process, chemical or hydrodynamic or thermal interaction. Even the stress and the fluid shear causes formation damage. The fluid shear is due to the production of oil or fluid. The contact between the fluid and the rocks create shearing stress, which cause like fine migration, which lead to plug the pore throats, which decrease the productivity. Even the deep wells had high value for the stress due to the Young modulus and Poisson ratio, which also lead to decrease the productivity and increase the damage at this zone. All this process triggered during the drilling, production, workover, even the stimulation, like acid or hydraulic frac, related to the fluid which we use to pump through the reservoir, which could be incompatible with the reservoir, which be like polymers, cause also plug the pore throats. It's very important when we work or study a well to conduct a stimulation technique to bypass or remove the damage, to define the types of damage and also its location. This table, it's like a guideline for a new well, old well, or injection well. What is the possibility of the damage type could be occur in different locations? So new well could be the damage due mud solids due drilling or mud filtration, or cement during cement squeeze during drilling, or cement squeeze during remedial workover. The old well could be scale deposition or corrosion, could be emulsion or clay swelling or paraffin asphaltene. This is very clear in the well which produced by ESV. Old well produced by ESV at a specific condition could be the plugs, the stage itself plugs with a scale, and it needs to conduct ESV backwash to pump like diesel or xylene or even acid to dissolve this acid. Sorry, to dissolve these plugs. Same for the injection well, could be scale deposition, could be clay swelling, due to the incompatibility between two fluids, between the injected fluid, like water, and the fluid, the reservoir fluid itself, as a water, or even the rocks itself. So it's very important before we inject any fluid into the well, into the reservoir, to conduct compatibility tests between the two fluid and between fluid and rocks. And also it's very important to conduct XRD to define the clay types into the formation. This chart also classifies the damage to 4 types: as a mechanical mechanism or chemical mechanism, thermal mechanism, and biological mechanism. All of this just a guide to define how we are going to deal into the reservoir, to select the proper technique and the fluid to enhance the productivity. All of us know Darcy equation, And this slide shows a difference between the damage zone to the undamaged zone. How can the damage zone affect the production of the reservoir? So here we can see at ratio between the damage permeability to the original permeability, like to be 0.1. The envision for water mud for 2 feet can cause up to 68% production decrease. And 1 feet envision cause 56% production decrease. This is just due to water-based mud envision. You can imagine another fluids, another effect on the production due to different causes or different processes. So it's very important to avoid the damage than to try to restore it, because it will cost due to operation, due to techniques, to the services, to try to get the well recovered from the damage. So the formation damage refers always to obstruction occurring in the well near wellbore. This reduces the well production and the injection capacity of the reservoir. This damage obstructs the natural flow of the fluid to the surface, so it could be exit in the formation, in the perforation tunnel, in the lifting system like the ESP or sucker rod, or even the side bucket mandrel in the gas lift, in the tubing, production tubing. It's important to that not all the types of formation damage require a removal treatment. Some types of damage will clean up during the production, and others can be removed by change in the operating practice. And as I mentioned, for the ESP wells, we could observe plugging performance during the first days of the production of the well, and while increasing the water cut, we can observe that the plugging decrease and the production increase. This change due to the operation parameter, change in the operation parameter like the water cut, like the drawdown, the high drawdown for the ESP would cause a scale formation into the pumps itself. So it's very important to select the optimum operating conditions for the production of well, to don't get into problem damage or like this. There are two types of the damage, either natural or induced. The natural occur primarily as a result of the reducing the reservoir fluid, and the induced is an external operation that was performed on the well, such as drilling, recompletion, remedial work, or injection operation. We need to determine the location of the damage. Is it near the wellbore as the perforation tunnels, or on the sand screen, or is this deep into the formation? So here, from this figure, we can show that scale could exist in different locations, tubing or gravel back or perforation or formations. We could observe also the emulsion into the reservoir or add the gravel back. The wettability change occur into the formation only. And the wettability change could be occur due to some additives to the acid recipe or to the frac fluid, like corrosion inhibitor or surfactant. A certain type of surfactant could be changed the wettability from water wet to oil wet. So it's very important to select the proper fluid compatible with the formation. Also, the geological depositional environment has a role in the formation damage. So the deposition of sediments is the first step. Second is the compaction and alteration process. The compaction of these depositions or the precipitation of the pore filling minerals, clay and cement and other materials, it's to determine the porosity value. So if these rocks are compacted and the clays are pore filling the porous roads, so I got finally a low porous media. So it's very important to define, to know the geological area that I have to go to deal with it to bypass the damage. One of the important factors cause damage into the reservoirs is the clay. So they define the clay to two types, indigenous and extraneous. Indigenous, like detrital materials that originate during the formation of rocks and have restricted formation damage potential because they exist as tightly packed and blended. But the diagenetic are formed by the contact between the fluids and the rocks, makes the sediments loosely attached as pore filling or pore lining or pore bridging. It's have a great formation damage potential because of their direct exposure to the pore fluids mineral within the rock matrix. So at the contact of the fluid during the injection or the production, cause fine migration along the reservoir, cause plug for the porous roads, decrease in production. And extraneous or foreign material introduced through the wells during drilling, workover operation, like mud could be contained solids, mud not compatible with the formation, cement material cause damage into the reservoir, using polymers also cause damage into the reservoir and decrease the productivity. So here show the location and different type of the clays and its effect on the porosity value. So we see the tight packed clays. It's good for me, but when the clays are suspended into formation, it leads to decrease the productivity, decrease the porosity. So the migrating fine can be a variety of different materials, clays or silts or kaolinite. And as we mentioned before, always the damage from the fines is located in the near well pore area within 3 to 5 feet radius. The clay swelling It's a phenomena in which water molecules surround the clay crystal structure, increase the structure's spacing, and thus resulting an increase in the volume of the clays, lead to decrease the porosity and lead to decrease the productivity. The clays change volume as the salinity of the fluid flowing through the formation change. So the reason behind the clay swelling is that a fluid incompatible with the reservoir fluid invaded through it with different salinity. This different salinity caused ions exchange, which lead to change in the structural spacing of the clays. The most common swelling clays are smectite, or has another name called montmorillite, or mixed between illite and smectite clays. Smectite swells by taking water into its structure, can increase to 600% of its original volume. So you can imagine what is the damage effect on the production could be occurred. Here, it's very important to conduct XRD to define the types of clay. When you found the result, mentioned that there exists of smectite or mixed clays, so you now know the truth. There is a clay swelling caused formation damage. So I need to inhibit this swelling. When I found a kaolinite, and it's one of the most common types of clay, this caused fine migration. So it's very important to make tests on the rocks as a core or even a samples from the reservoir, from the interested zone, to define the lithology of the formation and define the clay's type. And here we can see that as a first, there is a clays, fine grains adhere on the surface of the rocks, but with the fluid flow, there is suspended into the rocks, decrease the porosity. While P figure, the clays are lining on the surface of the rock. So it's very normal phenomena. Number C, it's pores, poor lining and poor filling. And finally, you can observe that the porous throats plugged induces fine migrations. Here also showed different type of clay and its location into the channels or in the pores and its effect on the production. So to deal with this phenomena, you need to inject a fluid to stabilize the clay and the fines. This is called clay stabilizers. It's a chemicals used to stabilize clays and fine function by being absorbed on the surface, usually by electrostatic attraction or ion exchange on the minerals be stabilized. Most of the clays has a silicate, silicon, with a negative charge. So the most effective stabilizer has a positive charge. So they deal with each other to prevent the ion exchange between the clay and the water once it contact with the rock. When I prevent this ion exchange, I succeeded to prevent the clay swelling. The clay stabilizers is one of the most important additives used in the acid recipe for the sandstone. And also it could be used with the frac fluid. The salt to mix the water like KCl or calcium chloride, also it's a type of the clay stabilizers. It's very important to define and to select the proper percentage or dose from the KCl or the salt to be used in killing as a killing fluid into your field, to select the compatible one with the reservoir during the killing fluid or during mixing the acid with fresh water or the frac fluid. Here is a conclusion for different type. The most of the damage types occur in a field, like fine migration, scale deposits, paraffin asphaltene, emulsion and potability, and water blocks. Each one of them has a technique to bypass and restore the original productivity. So, to get an introduction about the sandstone acidizing, and it's a very critical stimulation technique, because has a possibility to cause damage after the stimulation itself. So first, what is the sandstone mineralogy? Sandstone reservoirs are mainly composed of quartz. It's silicon dioxide. These sands particles are attached to each other with cementing material. The cemented could be clays and feldspars, or it could be carbonates. Like here, there is a quartz, there is a pore lining, there is a pore filling as a clay, as a kaolinite, as a illite. It could be cement material by carbonate. So also it's very important to define the lithology of the sandstone before conducting any stimulation. Here also a table showed the chemical composition for the minerals of the sandstone, like quartz, feldspars, clay, kaolinite, illite, cementite, chlorite. These are the different types of clay. Carbonate as a calcite and dolomite, iron oxide. So it's very also important to know the chemical composition for each mineral to understand the chemical reaction between these minerals and the acid which is going to be used for the treatment. This slide shows the rock solubility between hydrochloric acid, HCl, and mud acid, HCl plus HF. And it's called mud acid because initially they used this solvent to dissolve the mud minerals after the drilling. So it's called mud acid. So here we can observe that quartz and the feldspar doesn't dissolve in the HCl, but could be dissolved in the mud acid. The different types of the clays, kaolinite, illite, smectite, chlorite, has high potential to dissolve in the mud acid, but not dissolve it in the HCl. The calcite and dolomite dissolve in the HCl, but has a risk when dissolved in the mud acid because it could form a calcium fluoride precipitation, and the calcium fluoride precipitation plugs the porous throats and make huge formation damage through the reservoir. So here's the system of the mud acid. There are 4 types of the mud acid: the regular mud acid, organic mud acid, fluoric acid, and organic clay acid. The first one is the mud acid. How we can obtain the mud acid, how we can form the mud acid. On the location, we get ammonium bifluoride mixed with HCl, and the product is hydrofluoric acid plus HCl plus ammonium chloride. The HF and the HCl, it's called mud acid. So this product is due to the reaction between ammonium bifluoride and hydrochloric acid. The percentage of the ammonium bifluoride and the HCl is going to be mixed. This is determine the concentration of the mud acid used in the treatment. So I have 6 to 3% mud acid, 12 to 6 or 12 to 3. The higher number value is for the HCl and the lower value is for HF. So for 12,6 mud acid, this is 12% concentration of HCl to 6% concentration of HF. Why there is a difference in concentration? Because when I have a high value for the HF, so I have more power dissolving for the quartz in the sandstone. But also, I have more risk to cause damage after the acid stimulation. And anyone can ask why I couldn't get a pure HF on the location ready to be pumped into the reservoir. This is very risky and unsafe due to the mobilization or the transportation, or even with the dealing with the crew on the location to deal with pure HF. For safety issues, we get ammonium bifluoride and mix it with hydrochloric acid on the location to get HF. The second type is organic mud acid. So if I'm gonna to deal with a well or with a reservoir with high temperature, more than 250 degree Fahrenheit, the HCl, it will be corrosive. Its corrosiveness, high corrosive ratio for the tubing and for the pipes itself. So we replace the HCl with organic acid. So the organic acid is a mixture between 9% of organic acid, formic acid, plus 3% of HF. It's less corrosive than the mud acids. It easily inhibited to protect the tubing from the acid corrosion. So we replace the HCl with organic acid. So anyone can be asked why we don't use always the organic instead of HCl. because the organic acid is a weak acid. And to get the same dissolving power of the HCl, I need large volume from the organic acid. So the cost will be doubled or tripled for the job. So the organic mud acid used for the high temperature reservoir. Mud acid spins rapidly near the whirlpool and lead to decrease its effective in the reaction. So the solution using a retarder mud acid to go deep into the reservoir to deal more with the large volume of the quartz and feldspars and the clay. So they created another system called organic clay acid. This mixture designed for acidizing sandstone formation with high silt and clay percentage more than 30%. And when exists HCl sensitive mineral such as zeolite and chlorite. Even the different types of the clay are very sensitive to the HCl at certain temperatures. What is the idea of the organic clay acid? Here you can check the reaction after using organic clay acid or OCA. The organic clay, the idea behind the organic clay acid is using a chemical called boric acid. This boric acid reacts with LHF, and the product is called fluoporic acid. This fluoporic acid is always unstable in the water. So there is a hydrolysis process always works into the reservoir. So to get easily the fluoporic acid generate HF during the invasion into the reservoir until react with all the feldspars and the clay into the formation. So get better result, better improvement than the normal mud acid. The sandstone acidizing is conducted in multi-stage process, specific 3-stage process. The purpose of the sandstone acidizing is to create wormholes, but not to dissolve minerals and remove formation damage. The mud acid deals and it dissolves in quartz, silicate, and the formation clay. And for your information, the reaction rate is very fast with the clays than the feldspars than the quartz. So when the reservoir contains clays more than the feldspars, the reaction it will be very strong and get better results. As we say, the sandstone acidizing is conducted by or through 3 stages. The primary stage is the mud acid react with the quartz or the sand to form silica fluoride and ammonium fluoride. The second stage, the silicon fluoride react with the clay and the feldspars to release aluminum and silicon precipitation. And if I leave this precipitation, the whole job will be a failure job. And the final stage, the remaining aluminum fluoride react until all the remaining acid is consumed. Left in the well, silica gel and calcium fluoride and aluminum fluoride, which lead to decrease the productivity of the reservoir. How I can deal with all this risk in the acidizing for sandstone? Primary step is to conduct pre-flush. Is a fluid stage pumped ahead of the main treating fluid. It could be HCl 15% or 20% or even 7% of HCl. Could be ammonium chloride to displace any clays or any hydrocarbon before the main treatment go into the reservoir. Could be mutual solvent also to decrease any possibility for emulsion during the main treatment pumping. So the first step is to pump a pre-flush like HCl, ammonium chloride, mutual solvent. The function of this stage is to clean the pass before I pump it or squeezed the mud acid into the formation. Second one is the main treatment, the mud acid. It's the fluid used to remove the damage. The last stage is the overflush and is an important part of successful sandstone acid treatment. Its function to displace unreacted mud acid into the formation, to get the product away from the well bore, remove any fluids could cause change in the wettability. But it has a big function or important function. The overflush, it's always with HCl, between 7% to 15% HCl. Its function to keep the pH low at range 1 to 2 as a pH value, to keep the reaction of the mud acid is always continuous, because if the pH is increased to 5 or 6, the silica gel and the aluminum fluoride will be precipitated into the formation. The only thing, the only action to prevent this precipitation, to keep the pH low at 1 or 2, to prevent this to occur. The overflush with HCl to keep the pH low along pumping the job. Briefly, the different steps of the sandstone acidizing. We can see here the primary reaction between the HF and the clays as a fluorosilicate, and the product will be aluminum fluoride and fluorosilicic acid. And you can observe the silica gel in the image. It's like a crystals. This crystals plugs the porous roads. The second reaction between the fluorosilicic acid with the aluminum and silicon, which exist in the clays, and the product will be aluminum fluoride and silica gel, which caused a damage into the reservoir. And silica gel precipitation occurs when the initial HF is nearly consumed. So to avoid this consumption, I need to keep the pH low. So I pump it over flush stage as a hydrochloric acid. Last reaction or tertiary reaction between aluminum fluoride and the minerals exist in the reservoir lead to increase the precipitation of the silica gel and aluminum fluoride. So to avoid all this reaction, especially the secondary and tertiary action, I need to pump overflush with acid to keep the pH low along the job. Last topic today is the carbonate acidizing. That's easier, very easier than the sandstone acidizing. And it's not complicated like the sandstone. The target for the carbonate acidizing is to conducting pathways through the damage zone to increase the productivity. HCl acidizing difficult to model because the holes that form are large. They become the most important feature of the process. There is a different software could be create a model for the treatment, even as a hydraulic frac stimulation or for acid stimulation. And it could be also estimate the penetration interval for the fluid as a length or as a height or even as a width. Could be conducted for the hydraulic frac, could be conducted also now by the newest software exists in the industry for the sandstone. But it's very difficult to predict the behavior of the acid into the carbonate because it's formed wormholes which couldn't be predicted by any model. Acid used in the carbonate matrix is HCl or organic acid, like acetic or formic acid. And these acids are only able to dissolve the carbonate rocks, either limestone or dolomite. Organic acid could be used in the cleaning and opening the perforation, or as we mentioned before, when the HCl is problematic at high temperature above 250 degrees Fahrenheit. As you know also, the dolomite is formed by the transforming of the limestone rocks. And this process occurs when the magnesium flow into the limestone and causes the dolomite. The dolomite rocks are more porous and permeable because their crystals are larger than the limestone. Very important to know that carbonate rocks may not be pure and could be contain a silica mineral as a cementing material. Here, we can observe a different actual model for squeezing HCl into a core. From the left to the right, the only difference is the pumping rate or the injection rate. We used the same concentration, like 20% of HCl, but it's different or increasing the injection rate, like 0.25 barrel per minute to 0.5 to 1 barrel per minute to 1.5 barrel per minute. This value is logic when you pump the acid into or through a cold tube. But when you could pump the acid into a tubing 3.5 or 4.5, you can reach to pumping rate with high value, 4 barrel per minute, 6 barrel per minute. So once you could increase the injection rate, you get a better enhancement into the reservoir. You can go more deeply into the reservoir, but to certain limit. Because after certain limit, it's useless to increase the injection rate. This slide shows what I want to be clear. So this chart is a relation between the pore volumes and the injection rate, and match between the on the left side and the right side. So when you start pumping with injection rate like 0.25, you make something called phase dissolution. You pump with minimum rate, so just as the acid react with the near wear pore, some inches at the perforation tunnel. It's called a perforation. When you increase the injection, you go more deeply. When you increase the injection to 1.5 to 3 barrel per minute, you get the optimum model, the wormhole. But after certain limit, as it's shown in the graph, you reached the breakthrough limit. All the acid couldn't go deep into the formation. The acid only will invade the near wear pore. You failed to make a channel with good length to target the permeable zone. So it's very important to select the fluid type, the concentration of the HCl or the organic acid depend on the temperature of the reservoir, what you have deal with it. Also select the type of pumping, either in coil tube or pole heading from the tubing, or a coil tube and into the annulus between the pipe and the production tubing. And finally, the injection rate. Try to don't reach the breakthrough volume or the breakthrough injection rate to get the optimum dimensions for your reservoir. In the carbonate reservoirs, it's very important to use a diversion technique, especially when you have a long perforated interval. And as per standard or as per box, if you have more than 20 feet perforated interval, you need to use a diverter. Because if you have a multi-layers with different permeability, when you are going to squeeze the acid will go only in the high perm zone, and you failed to stimulate the other zones. So you need to use a diversion, and most of the diversion now is a chemical liquid, as a powder or as a cross-link. It's a gel. You can first pump the acid, then you, after that, pump the diverter. The fluid it gel the permeable zone. Then you pump other acid, the rest of the volume. So the rest of the volume will go to the other layer. Then you also pump diverter and so on. So it's very important also to check your perforated interval and select the optimum type of diverter that to be easily pumped and easily removed after the job by lifting with nitrogen, or just with the time could be degradable with the time or with the temperature, to restore your wells on the production very fast. That's only for today. I hope you get any valuable information and to don't waste your time without any valuable data. Thanks for your interesting and thanks for listening me. Thank you.
Thank you, Engineer Ahmed. I think that it was very interesting session, and I think that all the attendees have a new information. Just we have some questions. We have a question that is saying, what signs should a BT, a petroleum technologist, look out for in recommending a well as a candidate treatment? So he is asking about the criteria to select a candidate for acid stimulation.
A candidate well or what? Sorry,
a candidate well for acid stimulation.
Yes. So for the carbonate reservoir, most of the carbonate reservoir is candidate for acid stimulation. If there is no water contact near to the base zone, so it's preferable to conduct acid stimulation to increase the productivity, because most of the carbonates during the production will cause a fine migration and decrease the productivity during the production. Also, there is other sorry, I can't hear.
Yes.
Do I continue or there is something?
Yes, you can continue. Okay.
Okay. Also, there is other type of carbonates. It's not a fractured carbonate, it's a tight carbonate. So it's need to acid stimulation, and it's need an acid frac to try to enhance or bypass this tightness. So for the carbonates reservoir, if there is no any concern about the water contact, so it's preferable to conduct acid stimulation. For the sandstone, it's another scenario. You need to check and study the reservoir very good to check, first of all, define the damage in this reservoir. And second, conduct all the tests that you could be reached for the sandstone, for the reservoir, as a capillary suction test to check the clay swelling, as XRD to define the clay minerals, compatibility test between the fluids that you are going to be used in as a stimulation, or if it's an injector well, conduct a compatibility test between the water and the reservoir water and the water and the rock fluid, and see if what is the result, and decide if you are going to acid stimulation or hydraulic frac. It's more also there is a big difference in the cost between the acid stimulation and the hydraulic frac. So if you could succeed to enhance the well by acid stimulation, it will be very good, and you save cost. It's very high. This for your question.
We have another question. Is there any minimum data or information requirement to ensure successful acid treatment?
Yes, but it's the first thing and the most important data, your database about your field. I can say some theories and experience, but what I can say, all of what can I say, it's not matched with your field. So the first thing, your database, your experience about your field, the dosage you are used the type of the fluid, and the compatibility. But overall, the minimum data is the mud log, is the CPI, the petrophysical analysis for the reservoir, and previous pumping schedule for the same reservoir, and any compatibility or XRD test conducted for the same reservoir type, or if there's or other types of logs, especially for the carbonate FMI logs or core analysis.
Okay, thank you, Engineer Ahmed. That was the last question for our session for today. So thank you again for your time and for conducting such interesting session.
Thank you, Engineer Allah. Thank you for all.
Thank you, and also thanks for everyone that for attendance for our session today. And please make sure that we have many sessions into the upcoming days. We have a session into 24 of August. We have another session on 29. Then we will have another session on 3 of September. Then we will have another session on 13 of September, inshallah. Okay, so don't miss our session. It will be very valuable, and also you can get a certificate for attendance for that session. Also, I would like to remember you that if you wanted to register for the upcoming courses, the links were sent in the Zoom chat. Also, if you want to have a certificate for attendance for our session for today, I will send a link now on the Zoom chat to get a certificate. So thank you all and hope you good night, inshallah.